biGENIUS offers you three main areas for navigating and accessing your modeling objects. In the Project Explorer, you have access to all versions belonging to a project. Right-clicking a version allows you to access the version-wide settings. Here you can use the branching system of biGENIUS. This is also the area that allows you to access the installed generator. biGENIUS can generate the output you need to deploy your solution. The Object Explorer allows you to navigate, create, and manipulate your model objects. Model objects are grouped into folders of different object types. Environments let you manage multiple target environments like production or test environments. Source systems let you manage all your sources that you need for your data platform solution. Data warehouse objects are the heart of biGENIUS. These are the business model objects that make up your solution. You can expand every model object to get access to the respective generator implementation, which you can customize to your specific requirements. Selecting any node in the Object Explorer will also show the containing data inside the Item Explorer. The Item Explorer can be used to filter your model if you are looking for specific objects. In addition, you can use the Item Explorer to perform mass operations on multiple objects at the same time. Modeling biGENIUS mainly concerns the creation and manipulation of data warehouse objects. Depending on the generator you use for the active project, you will see a list of data warehouse object types in the data warehouse objects root folder. Different generators provide different types. In this example, I'm using a generator for a best practice dimensional data warehouse, which is based on Microsoft SQL Server. biGENIUS is using semantic model objects. This means that your model objects don't need to represent the physical architecture of your data warehouse that you want to generate, but rather represent the business level model of your solution. This is especially true for the generic type entity. Entities are essentially business model objects that will be transformed into physical database artifacts like tables, views, and stored procedures. In biGENIUS, we only create an abstract representation of this business object. Expanding a data warehouse object tells you how the generator is implementing this model object and what types of artifacts will be generated by the model information you provide. In the example, you see that the data warehouse object product will be used to create database structures for the cleansing area, the data warehouse core, and the data mart. For every layer, multiple database artifacts will be created, like tables, views, and stored procedures. The generator will extract and process the appropriate information from your model to generate the artifacts for each connected layer. After deploying your solution, you can immediately see how the model object got transformed into the physical objects in the target database. biGENIUS models can be created via two different approaches. Data-driven modeling allows you to create objects based on the structures of your existing source systems. Business model-driven modeling allows you to create objects without any knowledge about your sources. You can connect sources after you created your model. You don't have to make a decision for any of the two approaches. You can mix and match them however you want. Both approaches need a source system at one point. A source system can contain multiple discoveries. One discovery for every source system needs to be active. A discovery is essentially an imported state of the source table structure at a specific point in time. In order for biGENIUS to access this source structure, one discovery has to be active. The structure of the active discovery will be available to our model objects. Let's start with the data-driven approach first. From the active discovery, we will create three staging objects based on the source object's product, subcategory, and category. Next, we create entities based on these stage objects. We can see that these entities are already connected to the stage objects via data flow sets. Now we can connect our entities to each other via relationships. Relationships are creating foreign key terms automatically, so we only have to connect those terms to their appropriate source terms manually. And we're done. This approach is very helpful if your business model is very similar to your source systems. There is no need to recreate similar structures manually over and over. Let's create another object, this time with the second approach. We create a new sales fact model object. We add 5 new terms and configure the data types. Then we connect the product entity through a relationship. Now we can connect it to our sources. First, we create the stage objects that we need for our sales model object. Then we add a new data flow set for each source we just created. Now we connect the matching terms from the data flow sets. Finally, we connect the foreign key term that was created by our relationship earlier. In biGENIUS, it is possible to configure the generator inside a project to fulfill specific requirements you may have, or if you are not happy with the default behavior. The 3 main areas to configure the generator are dialogues for pre- and postfix settings, default columns, and custom properties. The dialog for pre- and postfix settings allow you to control naming conventions for the artifacts of your generated solution. biGENIUS ships a default configuration which can be customized by the user. For every single object the generator can produce, you will find the pre- and postfix setting inside the settings dialog. Adjust the values if they don't align with your naming conventions. The dialog for default columns gives you precise control about all technical attributes that are automatically added every time you create a model object. All your projects are already pre-configured with biGENIUS best practice values, but you can customize them to fulfill your requirements. You can also create additional or remove existing default columns. You can even configure the default behavior of every column by developing your own default term rules. The dialog for custom properties allows you to customize existing and create new biGENIUS model extensions. Custom properties are essentially additional fields that can hold any value and can be configured for almost all biGENIUS model objects. They can have a specific value type which is interpreted by the application to also provide an appropriate UI control in the Custom Property Explorer. Custom properties are available to the generator, which means you can extend the generator capabilities by accessing the custom property values during generation. If all these customization options are still not enough to fulfill your requirements, you can also customize the generator implementation itself. In the generator configuration, you have access to all the gears and screws that make up a generator. Extensive and in-depth knowledge about the generator structure is recommended to customize a generator at this level. biGENIUS generators are using templates to produce their output. Templates are essentially build instructions for the generator. They take model objects and generator configuration information as an input and produce appropriate output scripts depending on the supported generator technology, like SQL or Python scripts. biGENIUS generators already support a wide range of customization options. If they are still not enough to fulfill your requirements, you can even go so far to customize or rewrite templates of the generator itself. The stock templates that are shipped with every generator cannot be changed by users, but you can derive duplicates and customize those duplicated templates instead. A customized template is then recognized by the generator when it is linked to a model object. The links can be managed for every single model object. They can also be set as a new default template for all objects in the Default Template Settings dialog. If you need a reference on how and which data can be accessed via templates, you can use the External Model Viewer. The external model is an abstraction layer of the biGENIUS model you developed. It offers high-level data structures which are optimized for templates and can be better consumed by them. Every time you trigger the generator, an external model instance will be created from the current state of your model data, which is then provided to the templates. If you want to work on a project with multiple users at the same time, we suggest that you utilize the branching and merging capabilities of biGENIUS. Based on work versions, you can create new feature branches. They are essentially full copies of the work version with the exact same content. You can continue to develop your models inside the feature branch without changing the state of your data inside the work version. When you are done inside a feature branch, you can merge it back to the work version. biGENIUS will support you during the merge with a cherry-picking mechanism to give you full control about the data that should be merged. If you are working with multiple users, you could encounter issues when the work version was already updated with the feature branch of another user. Therefore, we recommend to regularly update your feature branch with the current content of the work version. If you want to maintain your release branches, you can also utilize feature branches there. This is often very useful if you encounter issues in your deployed solution and want to develop a bug fix in the biGENIUS model to also fix your deployed solution. On a release branch, you can create feature branches, which you can merge back into the release branch, or update your feature from the release branch.